Download this code and get free GPT-4o from codegive.com, link in the description below. Certainly. Formal Semantics for Multi-Language Programs by Amal Ahmed is a research work that explores the formal semantics of programming languages, particularly focusing on how multiple languages can be integrated and their semantics defined in a coherent manner. Below, I'll provide an overview of the key concepts from formal semantics, followed by an example that illustrates these concepts. Overview of formal semantics. Formal semantics, this is the study of the mathematical meanings of programming languages. It provides a rigorous way to describe the behavior of programs, allowing for precise reasoning about their correctness, behavior, and interactions. Key concepts in formal semantics. 1. Syntax. This refers to the structure of expressions, statements, and programs in a language. It can be defined using grammars. 2. Semantic domains. These are the mathematical structures that represent the meanings of expressions in a language, often defined as sets with specific operations. 3. Denotational semantics. This approach assigns meanings to programs by mapping them to mathematical objects, typically functions. 4. Operational semantics. This defines the meaning of programs in terms of the steps of execution. It can be described using transition systems or small step and big step semantics. 5. Axiomatic semantics. This uses logical formulas to describe the behavior of programs, focusing on what properties hold before and after program execution. 6. Multilanguage semantics. This involves defining the semantics of programs that may involve multiple languages, including their interactions, interoperability, and the semantics of language constructs that allow for this interaction. Example, defining semantics for a simple multi-language program. Let's illustrate these concepts using a simple example of a program that combines two languages, a functional language, like lambda calculus, and an imperative language, like a simple version of Python. Syntax. Assume we have the following syntax for our languages. Functional language. Expressions, e:= x lambda x dot e1 e2. Imperative language. Statements, s:= x equals e if e then s1 else s2 while e do s. Semantic domains. Functional expressions. The semantics of a functional expression can be given by a denotational model that maps expressions to their values in a domain of functions. Imperative statements. The semantics of imperative statements can be modeled using state transitions. Denotational semantics. For the functional expressions. Haskell. Denotational semantics for functional expressions. Data value equals closure, string dash value, number int bool bool. Eval, x bear dash env dash value. Eval, var x, env equals lookup x env. Eval, lam xe, env equals closure, backslash v dash eval e, x, v, env. Eval, app e1 e2, env equals case eval e1 env of. Closure f dash f, eval e2 env. For imperative statements. Haskell. Denotational semantics for imperative statements. Type state equals map string value. Eval stmt, stmt-state-state. Eval stmt, assign xe, state equals insert x, eval e state, state. Eval stmt, if es1 s2, state equals. If eval e state equals bool true. Then eval stmt s1 state. Else eval stmt s2 state. Eval stmt, while es, state equals. If eval state equals bool true, then eval stmt, while eval stmt state. Else state. ### conclusion. In formal semantics for multi-language programs, Ahmed's work likely delves deeper into how to formally define and reason about the interaction between languages, including type safety, execution order, and more complex constructs that arise in real-world programming. The example provided gives a basic understanding of how semantics can be defined for both functional and imperative languages, laying the groundwork for understanding multilingual programming semantics. For further details, I recommend reading Amal Ahmed's paper, which provides a thorough treatment of these concepts, including specific mathematical structures and proofs that support the claims made about the semantics of multi-language programs.